Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Isbukri bin Fahmi, and today I want to present my assignment 3, which is the in advanced differential equation. So this assignment, I will do it with my partner, which is Muhammad Nurani bin Kariman. So I will present the question 1 and question 2A. So let's go to the question 1. So the first one is the question one is a function fx is defined as fx 1 plus x with the interval is negative 1 until 0, and the second one is 1 minus x square 0 x until 1, and fx is fx plus 2. So the first one is we have to sketch the graph on the interval negative 3 until 3. So we go to the first one, which is the question A. So the first one we have to find what we have to find the point of the coordinate of the graph, which is we have to do the two equation, which is f. We have to put out the equation, which is fx equals to 1 plus x, and then we have to find the gradient and the y-intercept, which is the first equation is the m is equals to 1 and c equals to 1, and then we have to replace the x to the function, which is we have the first coordinate is negative 1 and 0, and the second is a 0 and 1. For the second equation is fx equals to 1 minus x square. So we have to find the gradient and the y-intercept, which is m equals to negative 1 and the c is 1, and then we substitute the x into the function, which is we get the first coordinate is 0 and 1 and 1 and 0, and then we plot on the graph, and then we get this graph, which is the interval is negative 3 until 3. So before I forget, we have to find the P4, which is the P equals to 2L, and the 2L equals to 2, and we get L is equals to 1. So that is a question for number A. So B, find the Fourier series of fx. So as we know, Fourier series is the formula of the Fourier series is A naught divided by 2 plus summation of an cos n pi x um, per L plus Bn sin n pi x per L. So that is the formula of the Fourier series. So we go to the question B. So as we can see, we have as I mentioned before, we have find the L which is equals to 1. So the first one we have to find the A naught, which is the formula is 1 over L uh, 1 over L, and the integration of the L with the limit L until negative L, which is fx and dx. So we put down the values, which is the L is 1, and the 1 and the upper and the lower is 1 and negative 1, function dx. So we uh, so since we have two functions, so we do for the two function, which is the first one we have the 0 until negative 1, 1 plus x, and the 1 until 0, 1 minus x squared dx. And then we do the calculation, and then we get the 7 over this for the a naught. So the second one we have to find the an, which is the formula is 1 over L, the integration, which is the limit is L until negative L, fx cos n pi x per L dx. So like a note, we have to put in the function and the formula, which is we get the 0 until negative 1, 1 plus x, and cos n pi x dx plus 1, 0, 1 minus x square cos n pi x dx. So how to integrate? We have to use the tabular method, which is there are two tabular methods that we use, which is the first one is 1 plus x is a u, cos n pi x is dv, and the second tabular method is the u is 1 minus x squared cos n pi x equals to dv. So this is the tabular method. So we have to the u is we have to differentiate, and the second one is we have to integration. So after that we do the drawbridge, and then we put the symbol, which is like this. We have to plus minus plus minus plus, and then we put on together, and then we get this uh, we get this statement of the formula. And then for the final answer, we get the 1 per n pi square minus 3 cos n pi per n pi square is which is equals to an, and then we got the an and a naught. So so for the bn is formula is 1 over l. The limit is l negative l fx n pi x per l. So like the a naught and the an, we have two functions. So we get 0 per negative until negative 1 plus s dx plus 1 0 1 minus x squared dx. And then we also use the tabular method to get the answer. And then we have to build the drawbridge and build the symbol, and then we combine it, and then we get the one log equation, which is we want to calculate the equation. And then for the bn, we get the final answer is 2 plus 2 cos n pi per n pi cube. But we have to uh, we have to we have to simplify it. So we get 2 over n pi square n pi cube, 1 plus in the in the blank, 1 plus cos n pi equals to bn. So the answer for the Fourier series, we put on the a naught, a n, and bn of the value on the formula, and we get 7 over 12 summation of 1 per n pi square minus 3 cos n pi per n pi square cos n pi x plus 2 per n pi cube 1 minus cos n pi sin n pi x. So that is the answer for the question 1 for the Fourier series at B. So the question 2 is I will present the question 2a. So which is first one is sketch the graph of the fx from negative 3 pi x 3 pi has determined whether the function is odd, even, or neither. So we see at the question is that fx plus 2 and 2 pi x 2 over pi x plus 2 for the interval negative pi x pi, and the fx plus 2 pi equals to fx. So as we can see, we can the first one we have to determine the gradient and the y-intercept, which is the gradient is the 2 over pi from the c is 2. So how we identify the y-intercept and the gradient. So since the function has given it, so we can put it on, so we can list down the gradient and the y-intercept. So so how we want to identify the coordinate, which is 0. So we have to substitute negative pi and pi to the equation, and then we get the first one in 0 and negative pi, and pi is equals to negative 4. And then we sorry to mention, so the p is equals to 2 pi, since the formula said is fx plus p equals to fs, so the p is 2 pi. So we have to draw the graph 0 pi, 2 pi, and 3 pi, negative 2 pi, and 3 pi. So because the interval said the question 1 to 3 pi, negative 3 pi and 3 pi. So we plot the first one is pi 4, the y-intercept is 2, and the negative pi equals negative pi and 0. So we draw. So since the limit is negative pi and pi, so this is the limit of the p is to 2 pi. So we draw another line until 3 pi, and the negative 3 pi until the 4. So this is the uh, the graph of the question 2a for the negative 3 pi x until 3 pi. So that is all for me. So the another of question 2b and question 3 will be presented by the Muhammad Nur Amni bin Kariman. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nur Amni bin Kariman. My student number is 2022830172. So today, I'll be explaining about my assessment 3, which is the group assignment for the course MAT565, Advanced Differential Equation. So today, me and my group mates, which is Muhammad Ismukri bin Muhammad Fahmi, will explain about our task for today. So the question that I'll be explaining is the question for question 2b. Here's the question 2b. As we know, 2L is equal to we can get the value of 2L from the function, which is equals to 2 pi. So the first one, we need to find the value for L. So we can come up with an equation which is 2L equals to 2 pi. And when you divide 2 pi with 2, you can get L equals to pi. And here's the equation given, which is for fx equals to 2 over pi x plus 2. And the first thing that we have to do is we have to find the value of A naught. So that's a fixed formula to find the A naught, which is 1 over L, and then fx dx. So we just sub in the value, which is value of L, which is pi. So A naught equals to 1 over pi from negative pi to pi, and then you insert the pi into the value of 2 over L x plus 2 dx. And here's the value. And then here you can deduct once you put the value, you can deduct the 2, and then you come up with x squared over pi plus 2x. And then you just sub in the value of pi. Pi square over pi plus 2 pi minus negative pi square over pi plus 2 bracket negative pi. And then you simplify until you can get the A naught equals to 1 over pi bracket 3 pi plus pi. And then you can cancel out the pi at the back of the 4. And then the final answer for A naught is 4. And then once we get the value of A naught, we can proceed to the next formula, which is we want to find the value of Bn. Same as just now, we use the fixed formula to find Bn, which is 1 over L, negative L to L, fx sine and pi x over L dx. So as we know, the value of L is pi. So we just sub in straight away, 1 over pi, negative pi to pi, 2 over pi x plus 2, sine n pi x over pi and dx. As you can see here, we can cancel out directly the pi, and it will become 2 over pi x plus 2 sine nx dx. As from here, you can see we cannot directly integrate. So we have to use the tabular method. As we know, we have to use the LIATE to know the value of u or the value of v. So from here, we know that the value for u is 2 pi x plus 2, and we have to integrate the v, which is psi and x. So once you differentiate u, which is 2 over pi x plus 2, you will get 2 over pi. And then once you differentiate again, you will get 0. From the tabular method, we need to differentiate the value of u until we get 0, then we stop. And then now we integrate the value of v. Once we integrate sine and x, we can get negative 1 over n cos nx. And then we integrate again, negative 1 over n square sine nx. And then we do this arrow, which is the first one is plus, and the second one is minus. Then we need to stop until we get 0 here. And then we can sub in again into this, to this form, which is 1 over pi bracket 2 over pi x plus 2 negative 1 over n cos nx minus 2 over pi minus 1 over n square sine nx. And then you have to bracket again and put pi negative pi. So now we can sub in the value for pi and negative pi into the equation, and we can get until here. And from here, as you can see, 1 over pi negative 4 over n cos n pi plus 2 over n square sine n and minus 2 over n square sine n. Right here, you can directly minus and you will get 0. And from here is the final answer. We just directly substitute, not substitute, just directly times the value outside here. And the final answer is negative 4 over pi n cos n pi. That is the final answer for Bn. And here's the Fourier series formula, which is we just have to sub in directly the value. As we know, the formula is fixed already. We just have to put the value. As we know, the Fourier series is fx equals to a naught over 2 plus summation of a n cos n pi x over l plus b n sin n pi x over l. And then the value just now that we get is a naught is 4. And then a n is 0 from the question. And then the value of Bn is negative 4 over pi n cos n pi. And then we construct again. So we come, the final answer for the Fourier series is 2 plus summation of negative 4 pi n cos n pi sin n x. That is all for the question 2b. Now I will proceed to the last question, which is the question 3. Here's the table that we need to do first, which is the step 1. We have to come up with a table. SR, YR, and YR sin XR, and the last one is YR cos 2 SR. From the given question, they only give you the value of SR and YR. So you have to calculate yourself for the value of YR sin SR and YR cos 2 SR. So you just have to directly insert the value using your calculator, and then you can get the value for these two. Okay, so YR does 4.11 times sin SR, which is 0. We get 0. Once you completed the table, you have to do the summation for all the value SR, YR sin SR, and YR cos 2 SR. And here's the summation for all the value. For SR is 1980, for YR 8.37, for YR sin SR negative 8.269, for YR cos 2 SR 4.225. So from the value of all the summation here, we can come up with a solution to find A naught, C naught, A1, B1, C1, alpha 1, A2, B2, C2, alpha 2. So the first one, we have to find the value for A naught. So from the given formula, 1 over 6 summation of YR. So the value of YR is 28.37, just directly times 1 over 6, you will get 4.728. For the C naught, the formula is half of A naught. So the A naught just divide by 2, which is 4.728 divided by 2, you will get 2.364. For the A1, the formula is 1 over 6 summation of YR cos SR. For your information, YR cos SR is a given by the question, which is 2.8997. But then that is not the value for A1. You have to divide by 6. So 2.897 divided by 6, you will get 0.583. And then for B1, 1 over 6 times YR sin SR, the summation here, you will get negative 1.383. For the C1, so you just have to use the formula here, which is A1 square plus B1 square. And then you will get, you just take directly from the previous answer value, and you'll get 1.465. And to find the alpha 1, which is the angle, as usual, just inverse tan A1 divided by B1. And then you will get negative 19.25. But then you have to plus 180. This is because it is on the third quadrant. So we need the real value. So the value is 160.749. And then we proceed to A2, same as A1, 1 over 6 times the summation of YR cos 2x. And the answer is 0.704. For B2, 1 over 6 times summation of YR sin 2 SR, you will get 0.769. For the C2, same as C1, use A2 square plus B2 square root, and you will get 1.043. For the alpha 2, just tan inverse A square divided by A2 divided by B2. And then you will get 42.473. So here's the value that we calculated just now from A naught until alpha 2. And then we can sub in directly into the Fourier series equation, which is fx equals to A naught over 2 plus summation of an cos nx plus bn sin nx. But then here's the longer version is A naught over 2 plus A1 cos x plus A2 cos 2x plus, let's say there's more than 2 period, you can add more, but then we only have 2. Then B1 sin x plus B2 sin 2x. And then here's the second one is C naught plus C1 sin x plus alpha plus C2 sin 2x plus alpha 2. Then here's the final answer, which is I sub in all the value. The answer is 4.728 over 2 plus 0.483 cos x plus 0.704 cos 2x plus plus minus negative plus negative 1.383 sin x plus 0.769 sin 2x. Then 2.364 plus 1.465 sin x plus the angle for alpha 1, which is 160.749, plus 1.43 sin 2x plus the angle for alpha 2, which is 42.473. So that is the final answer for the question 3. I think that is all from me. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.